Hello everyone, my name is Bharat and this video is a tutorial on using K-means clustering with the help of Eclipse. So in this tutorial we are going to use how we can do clustering for a huge set of data. And clustering is usually an unsupervised learning which is used for datasets which doesn't have a predefined class to find out. So for this tutorial I'll be making use of the segment.arff file which can be easily downloaded from website. This contains the data set of a few segments, and this is a Veka data set. So that's the reason we are having this .arff extension in it. So you can see the list of attributes which are present in it. So let us start by building the environment which is required for clustering. So to do so, let us create a new project and select the type as Maven. As we are going to do clustering, we would be needing a Maven or Scala IDE. Let us go through the default settings, and here let's give a name as Kmeans and finish it. So here you can see that a new project has been created. So let us try to rename this by changing the Java path to some other name like Scala. In a similar way, we'd be doing the same for test as well. So here I have changed the names of both these files from Java to Scala. So the next step would be to add Scala into the project nature. To do so, we can just right click and go to configure and choose add Scala to nature. So once Scala is added, we can change the Scala library container to a stable version by right-clicking on the library container and going to its properties and clicking on the 2.10 dynamic bundle, as we would be using the same version while importing the jar files. So now we have created the setup. So let us go to the pom.xml and add few dependencies. So here you can go and click on the dependencies menu and click on add. So this is the place I would be using the 2.10 jar files. Well, I've just opened the pom.xml, which is under the kmeans directory which we created. And if we just toggle through the dependencies tab, we can see that we have a UI which says us to add or remove few dependencies. Dependencies are a set of commands which we would be using right when we are compiling the code to run the kmeans. So for this tutorial, I have added a set of few dependencies which you can see I have highlighted here. These dependencies can be added by clicking on add and going and giving the group ID, artifact ID, and the version of the same, and by clicking OK. For this tutorial, I've already added all these four dependencies, and you would be getting the artifact name, the group ID in the document which is shared on Canvas. So let us continue by creating a new object. So to do so, let's right click and create a new object. So let's create a Scala object and let us name it as kmeans algo and click finish. So here we can see that a new object has been created which is open for us to code. So I've copied the code which was shared in the document and let us see by running this code. So I've copy pasted the complete code here. Here you can see it's a pretty simple code which helps us to get the number of clusters and the clusters to which each object is belonging. So here you can see that everything has been changed to two int and two doubles, and the code is all set to execute. So let us execute this code. To execute, we just have to right click and click on run as Scala application. So we can see here that it has executed successfully. Let me just increase the console tab. Here you can see initially it has read the data and few set of operations have been performed. Few things which we need to like remember here is would be the this is the sum of squared errors, we need to have a look at the end of the execution. We need to make sure that these values are kept at a minimum. Finally, if you go through the output, here you can see that we have an underscore one, which means that all the objects are belonging to the underscore one object, and the below zeros, ones, and twos would be the cluster to which each object is belonging. Say, for example, the first one would be belonging to the cluster 0, and the third one to 1, and so on. So this is an helpful code which helps us to find out what are the number of clusters and to each object is belonging to which cluster. If we just go up, we can also see that the cluster names have also been given here under the square braces, which helps us to find out the name of cluster or the location of each cluster which is present here. This is one way in which we can use K-means algorithm to find out the number of clusters and to which each object is belonging. I hope you enjoyed this video. Thank you.